Hello guys, so in this video we are going to look at computer memory units. So here we are going to talk about bits, we are going to talk about bytes, kilobytes, megabytes, gigabytes, terabytes, and then petabytes. And then we are also going to learn how to calculate and then convert these units from one form to another. Yes, so let's see how we go about this. Alright, so everything you see on your computer or your phone, whether videos, pictures, messages, apps, is stored and processed as data. But at the most basic level, all these data are just long strings of ones and zeros. So these ones and zeros are called bits, short for binary digits. So when you see the BI is the first two terms of the binary, and then the TS is the last two terms of the digits. So that's bits for you. Right, so we know that 8 bits make 1 byte. 8 bits make 1 byte. So let's take this bytes as our base, but for computers it deals with bits. So that's it. So let's try to break this down. So before we get a word, right, we have individual characters or single characters coming together to form a word. So a character is equal to 8 bits. So every 8 bit is a single character. Yes, every 8 bit is a single character. So if let's assume we want to spell the word it, we need two characters, right? So we need a character plus another character. The first character is I and the second character is T. So these two characters combined means that we have a word it. Now this word is going to give us 8 bits plus another 8 bits. 8 bits. So before you are able to store a word, you need 2 times the 8 bits to be able to store a word, and then this is supposed to give us 16 bits. Yes, so that's it. Before you are able to store a word, you need 16 bits of data. So our next thing that we're going to do is we are going to look at a table for these units. Yes, and then we see how we can be able to derive the other units when some units are given to us. So our first one is the kilobyte. So since I said we are using the byte as our base, 2 to the power 10 bytes gives us a kilobyte. 2 to the power 20 bytes gives us a megabyte. 2 to the power 30 bytes gives us a gigabyte. 2 to the power 40 bytes gives us a terabyte. And then 2 to the power 50 bytes gives us a petabyte. So when you check, you could see that this runs in multiples of 10. So when you check the first one, which is a kilobyte, we add a 10 to it, gives us a megabyte. So that's 20 plus 10, just gives us 30, plus another 10, that is 40, that's the terabyte, and then plus another 10, which is 50, that's the petabyte. So this is how you will be able to derive the other units when one unit is given to you. Yes, so let's see if we can solve some questions under this, just to give us a better understanding and a feeling of how these units can be manipulated. Yes, so our first question: how many combinations of megabytes and kilobytes makes a terabyte? So they're asking us to find the combinations of a megabyte and the kilobytes that can give us a terabyte. So when you check our table again, you can see that for a terabyte it is 2 to the power 40. So let's paste this there, and then just to as a point of reference. All right, so we are looking for the combinations of megabytes and kilobytes that gives us the terabyte. So when we check, we will see that A kilobyte is 2 to the power 10, whilst a terabyte is 2 to the power 40. Now, a megabyte is 2 to the power 20. So this means that 2 megabytes is going to give us a terabyte, but that's not what we are looking for. So we have 1 megabyte, right, giving us 2 to the power 20 bytes. Now, a kilobyte, right? 1 kilobyte is equal to 2 to the power 10 bytes. So when we check, we could see that we can't take 2 of the megabytes. So we need 2 of the kilobytes combined with 1 of the megabytes to be able to get a terabyte. So with this in mind, then we can say that 1 megabyte multiplied by 2 times of a kilobyte, where a kilobyte is 2 to the power 10. Yes, 2 times of a kilobyte will give us a terabyte. How? Okay, so let's see. A kilobyte is 2 to the power 10, right? So finding 2 times of it is 2 to the power 10 times 2 to the power 10 for the kilobytes. So let's do this. So 2 to the power 20, which is a megabyte, times 2 times of the kilobyte. So that is 2 times of 2 to the power 10 times 2 to the power 10, 2 times of the kilobytes. So now we have 2 to the power 20 multiplied by, from algebra, we know that if it's multiplying, we can sum them. So 10 plus 10. So this gives us 2 to the power 20 times 2 to the power 20. This is supposed to give us, we sum the powers again because the bases are the same. So 2 to the power 20 plus 20. Okay, let's shift this to the other side so we can get enough room there to continue our solution. Yes, so this gives us 2 to the power 20 plus 2 to the power 20 is 2 to the power 40. So 2 to the power 40. So when we check our graph, you can see that 2 to the power 40 gives us a terabyte, and that's what we are looking for. So the summary of this is that before we can get a terabyte, we need 1 time of the megabytes, or 1 of the megabytes, 1 megabyte, and then and 2 times of the kilobytes. Yes, so that's what the question asked us to do. If you can just take 2 megabytes, so 2 to the power 20 plus 2 to the power 20 will give us 2 to the power 40, which is a terabyte, but that's not what we are looking for. So now we've met the requirements of the question. So the second one, how many bits make 1 kilobyte? How many bits make 1 kilobyte? So let's tackle this question as well. How many bits make 1 kilobyte? So let's copy this and then paste it there as a reference. How many bits make 1 kilobyte? Alright. So from the start, right, when we started, we saw that 8 bits gives us 1 byte, right? So 8 bits gives us 1 byte. Bytes. Good. Now, to be able to get a kilobyte, we know that a kilobyte is 2 to the power 10 bytes gives us a kilobyte. So 2 to the power 10 bytes gives us a kilobyte. Yes, but we are looking for this in bits. So what we do is that we take the 8 bits and multiply it by the 2 to the power 10. So this means that we have 8 times 8 bits times 2 to the power 10. So this is going to give us 2 to the power 3 times 2 to the power 10. So when you have 2 to the power 3, it gives us 2, that's 8. So let's sum the powers. So it gives us 2 to the power 13 bits. So 10 plus 3, 2 to the power 13 bits. So we can also synthesize this or break this down as 192 bits. So 8192 bits, that's 8192 bits, gives us a kilobyte. So we've been able to solve the second question as well. So our final answers for the first one, we saw that the answer is 1 megabyte and 2 times of the kilobytes. For the second one, we saw that we need 2 to the power 13 bits to be able to give us a kilobyte. So that is what we did there. So to better understand this, you can try some questions yourself, and then yes, practice makes perfect. Yes, so that is what we have for today.